Okay, good morning, good morning, quantitative reasoning people. Today we're going to do compound interest. And I'm going to try to do this video quicker than usual because, well, the videos have been getting a little longer. So let's jump right in. So the main difference between simple interest, which you already learned about in the previous video, the 5 of you that did the assignment, thank you. The main difference between simple interest and compound interest is with compound interest, the previous interest amount is added into the new calculation. So that seems like a kind of maybe a difficult concept to grasp. You've actually already done this in Algebra 2. But let's explore this with a pretty simple example. So if you invest $100 at 10% for 4 years, how much will you have if you use a simple interest calculation? Well, we already know what that looks like. We're going to find the amount at the end, which means we're going to do $100 times 1 plus the interest rate, 0.1 for 10%, times 4 years. Right? That's just the formula that we had before, the simple interest formula. And it's $140. So simple, easy. So now let's take a look at compound interest and see what this is all about. So I have a little table here that I want to use to explore our compound interest. I'm going to need my calculator in a minute. So here it is. So at the very beginning, so I'm just obviously revealing this, right? So at the very beginning, at 0 years, we haven't done anything yet. We start with $100. So now we're going to do our little calculation here. Same calculation is right up here, only we're going to go for 1 year at a time. So we're going to get $100 at 10% interest, and we're going to calculate that for 1 year because we're going to go 4 years. So we're just going to see how much it is at the end of each of the 4 years. Sorry, at the end of each year, and then we'll see what it's worth at the end of the 4 years. So we have our $100, and we we increase by 10% for 1 year, and that obviously gets us up to $110, right? 10% of 100 is $10. Add that on, $110. So at the end of the first year, we have $110. Now, so in the previous example, we're just using $100 all the time, and we're doing 10% of $100 4 times. Now with compound interest, we're not going to do 10% of $100 as we did in the first step. We're going to do now 10% of $110, which is obviously going to give us a little bit more money. So again, we're going to do the same calculation. So now it's $110 times 1 plus 0.1, the 10%, for 1 year. And that's going to get us to $121. So now, again, instead of doing 10% of $100 for the next step, we're now doing 10% of $121 for the next step. So again, you can see compound interest is always taking the previous amount of interest and including that with our interest calculation for the next step. So here we are, 10% of 121, that's what's going on here. And we're doing the same calculation as before. So at the end of 3 years, we have $133.10. And so here we are, $133.10. We do it again. And at the end of 4 years, we have $146.41. So you can see that compound interest is better for us if we're making an investment, obviously, but not better for us if we're paying back a loan. So if we're going to pay back a loan, we're going to end up paying more. If we're investing money, we're going to end up getting more money. So either way, compound interest means more money. It's just a matter of whether you're paying back a loan or you're getting money from an investment. So hopefully you're getting money from an investment. So there it is. There's the difference between compound interest and simple interest. Nobody uses simple interest really anymore, so we're going to do compound interest from here on out. So all problems are going to be compound interest from here on out. Okay, so that's a little example to explain the difference between the two. I just got a few examples, and then we'll be done with our video. Okay, so we have a formula. And so I want to make clear that this formula here is so similar to the previous one, right? The previous one was A equals P times 1 plus RT. Well, this isn't quite that simple. Actually, I want to go back here just a bit. So you can see that for each one of these steps, if we do 0.1 times 1, that's obviously 0.1. So this is going to be 1 plus 0.1, or 1.1. 1.1, 1.1, 1.1. And in fact, we're multiplying by 1.1 1, 2, 3, 4 times. So 1.1 times 1.1 times 1.1 times 1.1 is 1.1 to the fourth power. So this answer right here, we could get by just doing $100 times 1.1 to the fourth power. You can check that out yourself if you want, but that's what we're going to get. So that leads us into our formula right here. So we're going to make this formula slightly more complicated because there are different ways of compounding the interest. We could compound the interest daily, monthly, weekly, semi-annually, annually, or whatever. So we have to take that into account in our formula. So we still have our interest rate. That's still going to be R, just like it was before. Only now we're going to have this additional variable, n. And n tells us the number of times we're going to compound each year. So that's an important piece here. Number of times compounded each year. And then we have an exponent here, just like I just described just moments ago. Obviously, we have to have a power to do this, right? We had fourth power because it was 4 years. So here we're going to do n times t, and we're going to talk about that in this very next problem. So here's your formula. This is the important formula for compound interest. This is what we're going to be using for a while, or some variation of this. Okay, so let's actually use this formula. So we're going to deposit $7,500 at 6% for 5 years, compounded quarterly. So quarterly means 4 times a year. That means n is going to be 4 in this formula right here for this problem. So A, which is, we don't know A. P is the principal, $7,500. That's what we're starting with right now. And then we got 1 plus R, interest rate is 6%. That's 0.06. A couple of you had some difficulties with the whole moving the decimal place twice a few times in the previous assignment, so just reminding you there. Move the decimal place twice to the left. And n, of course, as I said, was, so we're going quarterly, so n is 4. And then we're going to do to the n times t. Well, n is 4, and t is 5, so that's 4 times 5, so that would be 20. So let's do some calculations here. So just get out my calculator, and we're going to do 0.06 divided by 4 equals 0.015. So now we have $7,500 times 1.015 to the 20th power. So I'm just going to raise that to the 20th power. To the 20th power makes, that's not quite what I wanted here. I forgot to add 1. So 1.015 to the 20th power equals, that's 1.34 blah blah blah. So I should write that down. So what does it say there? 1.3469. 1.3469. 7,500 times 1.3469. And that's going to equal times 7,500. Boom. And we got $10,101.41. $10,101.41. And so obviously with this, we're always going to use 2 decimal places because we're dealing with money. So it's always about cents right there. So the question is now, so that's just using the formula just to calculate. And then the question is, how much interest did we earn in the 5 years? Well, that's easy enough to figure out. We started with 7,500. We ended with that. So all we need to do is subtract 7,500 from that. So we do 10,101 minus 7,500 equals 2601.41. 2601.41. So that's how much interest we made. So in 5 years, we just put the money in this account, and the account did all the work, and we just chilled, and we made $2,601.41 just waiting around for 5 years. So it's a pretty good idea. And when we talk about investing for retirement, you're going to see how important it is to invest early. Okay, so I left too much space for that. So we can compound periodically. So we can compound, like I said, monthly or weekly or quarterly or biannually, twice a year. Or we could compound continuously, which is all the time, every moment of every day until the compounding or the compounding period is done. So, so that gives us a new formula here. So it's an exponential formula. And remember that E is equivalent to 2.718. It's a constant. On your calculators, you can also find the value of E exactly on your calculator. Well, rounded to the nearest 20 decimal places or whatever, but 2.718 will be fine for us. So we're going to use our formula here if we're going to compound continuously. So it's different than compounding periodically. So let's check it out. Check out the formula. So we're going to invest $8,000, 6 years at that percentage. What are we going to have at the end? Well, again, it's easy enough. We just plug the numbers into the formula. So A equals 8 G's times 2.718 to the point, right? We're just using the formula here. There's the interest rate. So P was 8,000. E is 2.718. R is 6.85%. So we're going to move the decimal place over twice, 0.0685. We're going to multiply that by the amount of time, which is 6 years. Okay, so 0.0685 times 6 equals 0.411. So 8,000 times 2.718 to the 0.411. So we do 0.2718. I'm sorry, 2.718. 2.718 to the 0.411 equals 1.5083. 1.5083. 1.5083 times $8,000. And that gets us times 8, 1, 2, 3. 1266.09. 1266. 66.09. Okay. So there it is. So we got $12,000, $66.09 if we invest $8,000 for 6 years at that percent continuously. Again, just chilling, we made $4,000. Just waiting. So again, this is going to come into greater focus when we look at retirement accounts. Okay, so now let's take a look at something similar. You could invest $8,000 for 6 years, just like the previous problem, at 7%, different interest rate, compounded monthly, not continuously. How much do you have at the end? So we're actually just going to do a comparison here. So we're going to plug all those numbers into the formula here. So we got $8,000 times 1 plus R over N. R is 0.07. Move it over twice. We're going to compound monthly. That's 12. And we're going to do that for 6 years. So 12 times 6, aka 72. All right, so I'm just going to do all of this calculation on my calculator right now and write that number down. So 0.07 divided by 12 equals, add 1 equals, to the 72 power equals, and I get 1.5201. 8,000 times 1.5201. And that makes, times 8, 1, 2, 3, boom. That makes 12,160.84. 12,160.84. So here's the question. Oops, there we go. So which is better? 6.85% compounded continuously, or 7% compounded monthly? Well, 7% monthly got us 12,160.84. 6.85%, which is less than 7%, by the way, compounded continuously got us 12,066. So that's actually pretty close. But as it turns out, compounding at a higher interest rate monthly, in this case, got us a better situation. So, but it was close. So the moral of the story here is the more frequently you compound, the more money you make. And so, like I said, with the lower interest rate, 6.85%, compounding continuously almost got us the same as 7% compounded monthly. So compounding continuously is pretty much the way you want to go. Credit cards, by the way, are compounded daily. Okay, so which is better? As it turns out, the 7% monthly is the better way to go in this particular case. Different numbers, it could be different. All right, so calculating present value. Same as with simple interest, present value is the same approach. So we still have our same formula. A equals P times 1 plus R over N to the NT. And remember, present value is just this guy right here. P for present value or P for principal. So we're going to know the amount at the end, and we're going to know all this stuff right here. We're just going to need to calculate P. Easy stuff. So we're going to have A. We're going to calculate all this into one single number. Divide both sides by that number. We're going to be done. All right, so how much should be deposited? That's that amount right there. In an account that earns 6% interest monthly to have $20,000 at the end of 5 years. So just plug the numbers in. So we got 20 G's. P we don't know. 1 plus the interest rate, 0.06. For how long? Or actually how often? Monthly. So that's 12 right here. To the NT, so that's 12. Because it's 12 times a year, that's N, 12. And T is 5. So 12 times 5 years. So again, I'm going to do all this calculation over here on my calculator. So 0.06 divided by 12 equals plus 1 equals to the 60th power, because 12 times 5 is 60, and I get 1.3489. 1.3489. P times 1.3489. $20,000. So I'm just going to divide 20,000 by that number right there, and I'm going to have P. $14,827.44. 14,827.44. So if we invest $14,827.44 for 5 years at 6% interest, we're going to have that at the end. And you can see a little, you can see a little foreshadowing here, because what we want to do eventually, when we do our calculations for retirement accounts, is let's say that we want to have $1 million at the end of 35 years. And so we do all our calculations this way, and then we'd figure out how much do we need right now to deposit. But fortunately, we have annuities, so we don't have to have a big chunk of money right at the very beginning. Okay, last example. Okay, so you see advertisements at banks, and they say that we have 5% compounded daily or something like that. So what we want to know is, what does that really mean? So 5% APR, which is annual percentage rate, compounded daily. So this doesn't mean that you're going to get 5% at the end of the year. You're going to get something a little bit more than that, because we've already talked about the power of compound interest. So what is it that you're really going to make at the end of the year? So if you invest $100, and if you're just getting 5% at the end of the year, well, you'll have $105 at the end of the year. We already got that. We already figured that out. But the question is, what are you really going to get if you compound daily? So we have this cool little formula here. This is the effective yield, because it's not really going to be 5%, it's going to be something else. So we're going to plug that stuff right into this formula right here. Notice that there's no t here. There's no time because we're only working with 1 year for this particular formula. So it's always going to be 1, so we don't even bother to write it. So let's just do the calculation. It's really simple. So y equals 1 plus r, so that's 0.05. Compounded daily, well, how many days is there in a year? 365. And then to the nth power, 365. We're going to subtract 1 just so we can get the additional percentage, not what we already had to begin with. So we're just going to do the calculation right there. So 0.05 divided by 365 equals, and that's just some crazy number, some little tiny number. We're going to add 1, and then we're going to raise that. So that turns out to be 1.1230, 13699. Now I went a little crazy there, but it really does make a difference when you're going to raise this to the 365th power. We want to make sure we're as accurate as possible. So I'm going to raise that to the 365th power, and we get 1.0513 minus 1 is 0.0513, and we turn that into a percent, so we get 5.13%. So when they advertise 5% compounded, 5% annually compounded daily, what you're really getting is 5.13%, which is actually better. So why don't they just say you get 5.13% at the end of the year? Who would know? But there it is. There's your yield calculation, your yield formula, and that's the problem. So done in 22 minutes, not too bad. So hey, please do the assignments. Tell your friends to do the assignments because we're kind of winding down here. And remember, I know this is going to be painful to hear, but for those of you who want the credit, the free college math credit, the free one, you need to stick it out for another couple of weeks after the other seniors are done. Probably it's going to be about 2 weeks. So, but I want to emphasize, the faster you go, the more work you do, the faster we get done and the sooner you get out. So, so keep that in mind. You know, you don't want to have to set up situations where you got to reassess. Tell your friends, let's get this stuff done. Dig in. We're almost at the end of the race here. Just, you know, we can do this. So we'll get this done together. It'll be great. So, yeah, see you guys on Monday. Have a good weekend. Be safe.